Hello, welcome to my channel. We have been solving these past papers. So right now I have this mathematics pure math 2 paper. It's from May, June 2024. So we have already done 3 questions in this paper. So let me go to the question number 4. You can check this previous question in my this question number 1 to 3 in my previous videos. So let us start this question number 4. Okay, so to prove this identity, uh, okay, so I hope you know, or let me drive it again. What is the formula for tangent alpha plus beta? Okay, so this is sine alpha plus beta over cos alpha plus beta. So this would be sine alpha plus beta, I mean sine alpha cos beta plus cos alpha sine beta. And cos alpha plus beta is cos alpha cos beta minus sine alpha into sine beta. Okay, now I will divide everything by cos alpha cos beta. Okay, so when I divide this part with cos alpha cos beta will cancel, and sine alpha over cos alpha will come tangent alpha. So this is tangent alpha plus. Similarly, I divide this thing by cos alpha cos beta, so cos alpha will cancel, and sine beta over cos beta will be tangent beta over. This will become 1, right? Okay, and minus sine alpha over cos alpha is tangent alpha, and sine beta over cos beta is tangent beta. So this is the formula for tangent alpha plus beta. Now, what about tangent alpha plus alpha, or theta plus theta, or 2 theta, right? So tangent 2 theta would be, if I put for alpha and beta, I put alpha theta again for both of them. So tangent theta plus tangent theta is going to be 2 tangent theta. Similarly, divided by, I have 1 minus tangent theta into tangent theta is tangent square theta. Okay, this is the key. This is clear. Similarly, what about tangent theta plus 45? So this would be tangent theta plus tangent 45 over 1 minus tangent theta into tangent 45. And tangent 45 is 1, so it's going to be tangent theta plus 1 over 1 minus tangent theta. Okay, so from these two, let's start the left hand side of this expression. So left hand side is given as 3 times tangent 2 theta plus tangent theta plus 45, right? So 3 times tangent 2 theta would be 2 tangent theta divided by 1 minus tangent square theta, and plus this would be tangent theta plus 1 over 1 minus tangent theta. Okay. Okay, so let's add them together. I have this is 1 plus tangent theta and 1 minus tangent theta, right? I can factorize this part. And then I have 6 tangent theta. And similarly here I have tangent theta plus 1 over 1 minus tangent theta. So when I try to add them together, the common denominator is going to be 1 plus tangent theta into 1 minus tangent theta. Okay, so this is going to be 6 tangent theta plus this would be tangent plus 1, and it should have only 1 minus tangent theta, so I will multiply again with 1 plus tangent theta. I hope this is clear. So now I can simplify this fraction. Okay. In the numerator, I have 6 tangent theta plus, this is tangent plus 1, tangent plus 1, this is tangent plus 1 squared. So I can expand this square as tangent square theta plus 2 tangent theta and plus 1, right? And the denominator, I can combine that together again. So this is 1 minus tangent square theta. Okay, so this will be tangent square theta and 2 tangent theta and 6 tangent theta will become plus 8 tangent theta plus 1 over 1 minus tangent square theta. Okay, so let's set, is it the right hand side? I have to go there. Yeah, tangent square plus 8 tangent plus 1 over 1. Yes, so this is the right hand side. Okay, so we prove this identity. Okay, now let's move on to question B. Okay, hence solve the equation. Okay, okay, so this left side, okay, we just saw that this is, okay, let me write it again, 3 tangent 2 theta plus tangent theta plus 45. This is equal to, we just saw the tangent square theta plus 8 tangent theta plus 1. Make sure. Yes, and divided by 1 minus tangent square theta, and this whole thing is equal to 4, right? This is the 4. Okay, so I have to solve this equation where theta is between 0 and 180 degree. So you can see if I take, if I simplify tangent square theta plus 8 tangent theta plus 1 is equal to, when I multiply this denominator on the other side, it will become 4 minus 4 tangent square theta, right? Okay, so tangent square theta, 4 tangent square theta, if I take on the other side, it will become tangent 4 plus 1, this is become 5 tangent square theta plus 8 tangent theta. And when this 4 comes here, become minus 4, so this is become minus 3 equals 0. Okay, so this is the quadratic equation I need to solve. So let's assume that tangent theta is equal to x. So this expression will become 5x squared plus 8x minus 3 equals 0. Right? So I can use quadratic formula to solve it. So x equals minus b plus minus under the root b squared, which is 8 squared minus 4 into a into c is minus 3. So I'll make it plus and 3 here. And divided by 2a. So it is 2 times a. Okay. So this thing when simplified, I got two answers, 0.31355, and the other answer is minus 1.9135. Okay, so of course this x is equal to tangent theta, so it means tangent theta is equal to 0.31355. So theta is equal to tangent inverse 0.3155, and this gives me the answer of 17.41 degree. Okay, now the second answer was tangent theta equals negative 1.91355. So theta is equal to tangent inverse negative 1.91355, and this gives me a value of, let me use my calculator. Oh my goodness, this is what. My calculator is not working properly. Okay, anyway, this, okay, remember when I did this thing, it gave me a negative angle. Okay, but I had to find an angle between 0 and 180 degree. Okay, and I know that tangent theta is periodic with an angle of 180 degree, right? So whatever angle I got, if I just add into it 180 plus, it will give me the angle which is in this range, and it is correct angle. So that angle I found as 117.59 degree. Okay, so these are the two answers for this particular question. Okay, now let's move on to question number 5. Oh my God, what happened to my calculator? Okay, yes. So a curve has this equation, y equals 1 plus e to the power 2x over 1 plus 3x. Okay, and it has only one stationary point. So find dy by dx and then show that the x coordinate of p satisfies this equation. Okay, so let's find the dy by dx derivative of this function. So this is going to be a quotient rule. So I will use denominator of lower function 1 plus 3x into derivative of the upper function, and that is going to be 0 plus e to the power 2x into derivative of 2x, which is 2. Okay, minus upper function 1 plus e to the power 2x into derivative of the lower function, and that's going to be 0 plus 3, right? And divided by square of the lower function. So 1 plus 3x and its square. And this has to be equal to 0, right? In order to find the stationary point, I need to put the derivative equal to 0. So let's solve it. Let's solve it. So this is going to be 2 e to the power 2x into 1 plus 3x into this. So this will become 6x e to the power 2x and minus 3 and minus 3 e to the power 2x equals 0. Okay, so if I rearrange it a little bit, I will leave this thing on the left side. So this is 6x e to the power 2x equals, on the right side I have this, this and this. So minus 3 and plus 2, this is minus 1, and the other side will become plus 1 only. So it is e to the power 2x only and plus 3. Okay, I hope it's clear. I'm not confusing you. So now I divide everything by 6 e to the power 2x. So on the left side, I have only x equal e to the power 2x divided by 6 e to the power 2x plus 3 divided by it 6 e to the power 2x. So this is going to be 1 over 6 only, plus this is going to be 3 over 6 is 1 by 2. And if I take it on the up, it will become e to the power minus 2x. Okay, so in order to find the stationary point, I need to solve this equation x equals 1 by 6 plus 1 by 2 e to the power minus 2x. Okay, so the x coordinate of this stationary point satisfies this equation. So we just prove this point. Okay, now the next question is a little bit more involved. Show by calculation that the x coordinate of P lies between this and this. Okay, you see, this is not easy to solve. This equation is not easy to solve. Okay, let me show you graphically that what is meant by this equation. Okay, so x, if I, let's talk about two functions. One function is x, the left side, and the other function, let me call it g of x, it is the right side, which is 1 by 6 plus 1 by 2 e to the power minus 2x, right? So we have to find the value of x when both functions are equal. Okay, so this function is easy. The first one, it is just a straight line, right? So this is f of x equals x. Now the second function, it when x is usually x is on this side, and this is f of x and g of x. This is on the y-axis. Okay, so when x is 0, it is 1 by 2 plus 1 by 6, and that was 2 by 3. Okay, so this point is, let's say, 2 by 3, or okay, let's make this point 2 by 3. 2 by 3. So it starts from here and it goes something like this, and it become horizontal at 1 by 6. Because when x is very large, this will become 0. So I have the g of x will stay at 1 by 6, right? Okay, so we need to find this point where both functions are equal. Okay, so at this point we need to find where the both functions are equal. Okay, so we just saw that if x is equal to 0.35, okay, if x is 0.35, then you can see that f of x is 0.35, but g of x, when I evaluated it, it gave me a value of 0.414. Okay, so you can see that 0.35 is before this point, 0.35, because f of x is small and g of x is large. But if f of x is 0.45, right? So then you can see that f of x is 0.45, but g of x, when you evaluate it, it comes out to be 0.3 and I believe 7, which means this point, 0.45, must be after this 0.45 somewhere here, because at this point, g of f of x is larger and g of x is smaller, right? So that proves that my solution lies between these 2 points, 0.35 and 0.45. Okay. Now this first part, yeah, I did it up on the upper page. Show by calculation that the x coordinate of P lies between these 2 points. Okay, and now this part. Uh, Use an iterative formula based on the equation in part A to find the x coordinate of P correct to 360. Okay, uh, how can we do this iteratively? There are several techniques, and I'm not sure which have been taught to you guys at this stage, but what we can do, I haven't done it, so I will just explain how you should do it, how you should try it. So make a table. Here you have f of x is equal to x, and g of x equals 1 by 6 plus 1 by 2 e to the power minus 2x. Okay, and we know that answer is 0 between 0.35 and 0.34. Uh, sorry, 35 and 45. Sorry, yeah. Okay, so when x is 0.35, this was 0.45. Sorry, 415, 414, and when this is okay, this is 0.37. Okay, so we need to find a value in between which is for which they're both equal. So next thing I will try is in between those two. So this is 0.4. Okay, and if it is this, so you can find the value what is over here. Now, if it is above zero point 0.4, then you have to see that I should go a little below. If it is below, I have to go a little above. So you do several iterations, and then eventually you will find some kind of conversion here. Okay. Unfortunately, right now my calculator is not working. It stopped doing something, so I cannot help you. But if you, I hope I've explained it very well. But if you have any question, you can always be in the comment section, and I can redo this question for you. Thank you for watching. If these videos are helpful to you, then please subscribe to my channel. That will be your help to me. Thank you very much for watching. See you in the next video.